In the realm of science and colossal mysteries, the question of what existed before the Big Bang has sparked debates and fascinated minds for centuries. This profound question not only challenges our understanding of the universe but also pushes the very limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast unknown, and wondering what lay there before our universe was born. The event of the Big Bang marked the beginning of history, space, and everything we know. But was there a moment before this? 30 seconds. Perhaps before the Big Bang, there was a state of nothingness, a silence before the grand symphony began. But if that were true, what kind of nothingness was it? Or was there something far more enigmatic that existed before time itself? As we dive deeper into this question, science takes us on a journey beyond the universe's origin into ideas that defy our comprehension. Physicist Brian Cox, known for his contributions to wonders of the universe, suggests that something astonishing could have existed before the Big Bang. He challenges us to rethink our understanding of reality and existence. In this exploration, we will dissect the science, theories, and perplexing mysteries that may explain what existed before everything. We will examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The revelations we uncover may astound you, but they may also provide new insights into our place in the universe. Prepare to delve deep into a realm beyond imagination, a scientific frontier where the unknown still lingers in the shadows, leaving scientists both awed and, at times, unsettled. 1 minute and 35 seconds. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang actually was. The Big Bang, as science describes it, refers to the moment when the universe became extremely hot and dense, rapidly expanding to create all matter, energy, and fundamental forces. When we look into the night sky, we see evidence of this fiery beginning, with galaxies expanding outward from a single point. But why did this happen? Was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or silent. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and vast, much like a cosmic vacuum. However, this vacuum was not completely empty. It contained an enormous amount of energy that fueled the rapid expansion of space itself. 2 minutes and 37 seconds. This expansion, known as inflation, occurred so rapidly that it essentially set the stage for everything that followed. In a fraction of a second, space expanded at unimaginable speeds until the inflation slowed, and its energy transformed into particles, forces, and matter, ultimately leading to the Big Bang. But what was the nature of this energy? Why did it emerge seemingly from nothing? And why did inflation eventually stop? Scientists believe that this rapid expansion created different patches of the universe, each experiencing its own Big Bang. Imagine a vast fabric stretching infinitely, with tiny air bubbles forming. Each bubble represents a universe, including our own. This concept, known as the inflationary multiverse, suggests that there may be countless Big Bangs and innumerable universes. Ours is just one among many. 3 minutes and 43 seconds. This mind-bending idea challenges our very understanding of the universe and raises the question, what else is out there? The notion of nothingness before the Big Bang is purely theoretical, not an established fact. Even if we were to strip away all energy, particles, and radiation from the universe, it still wouldn't be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that form a fundamental cosmic tapestry. Even in its most barren state, space itself has properties, laws and constants that prevent it from being completely void. Imagine creating a region devoid of anything, no particles, no radiation, no energy, yet quantum fields and fundamental constants would still exist. 4 minutes and 47 seconds. This leads to an intriguing concept known as zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still appear and disappear, creating a ghostly resonance of activity even in what should be empty space. This challenges our notion of true emptiness and suggests that even before the Big Bang, something existed. Scientists are still exploring this as one of the most astonishing theories in modern cosmology. 5 minutes and 19 seconds. One of the most fascinating ideas is eternal inflation. If inflation created our universe, it's possible that it has been happening endlessly. Brian Cox describes an unimaginably vast inflationary multiverse, where universes are continuously created and expanded. Imagine each Big Bang as a spark igniting another universe while inflation occurs in various regions, forming countless other universes. This process, in theory, could go on forever. 5 minutes and 53 seconds. This idea of infinite universes leads to the concept of a fractal universe, where each new universe might, in turn, create its own Big Bang. Each universe exists as a separate space, unaffected by others due to the rapid expansion of space itself. For scientists, this hypothesis is both thrilling and unsettling. It suggests an endless multiverse with no definitive beginning or end. Imagine our universe as just a tiny speck in a vast, limitless structure, constantly generating and birthing new universes. And what if that is the true nature of reality? A timeless pattern of universes forming, evolving, and continuing in an eternal cycle? 6 minutes and 28 seconds. Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. It's an intricate network of energy fields that permeate the cosmos, interacting to form everything we observe. These fields behave like invisible oceans, with particles acting as waves or disturbances. Even when the fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can spontaneously appear and vanish, borrowing energy briefly before returning it. 7 minutes and 36 seconds. This characteristic leads to the phenomenon of virtual particles, particles that momentarily exist before disappearing. The existence of virtual particles challenges the possibility of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have true nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, quantum fields would remain active, sometimes producing fleeting particles. This constant activity suggests that the universe resists total emptiness. These fields and forces persist, filling space with latent energy that prevents absolute nothingness. 8 minutes and 8 seconds. This raises a fascinating question. If quantum fields generate particles, and particles form matter, could the universe itself have emerged from this nothingness filled with quantum fluctuations? 9 minutes and 10 seconds. Another compelling idea is cyclic cosmology, which offers an alternative to the Big Bang as a singular event. This theory proposes that the universe undergoes massive cycles of birth, death, and rebirth. Instead of a one-time creation, the Big Bang may have been just one phase in an eternal cycle of expansion and contraction. 9 minutes and 41 seconds. In this model, our universe may have emerged from the remnants of a previous universe. The process of compression and expansion in a cyclic pattern suggests that there was never a true beginning, only an ongoing sequence of universes forming, evolving, and regenerating indefinitely. Cyclic cosmology raises profound questions, as it suggests that time itself repeats rather than progresses linearly. If this theory is correct, it could mean that, far from being a singular event, the Big Bang was simply one chapter in an endless cosmic cycle. If the universe is part of an eternal cycle, then what happened before the Big Bang? According to cyclic cosmology, there may have been a previous universe that contracted before rebounding into the one we know today. This process, known as the Big Bounce, suggests that the universe oscillates between periods of expansion and contraction indefinitely. One of the key implications of this theory is that time may not have a true beginning. Instead of a singular moment of creation, time could be an endless loop, an infinite sequence of universes being born, evolving, and collapsing, only to be reborn again. But if this is true, what caused the contraction of the previous universe? Some scientists propose that dark energy, the mysterious force driving the accelerated expansion of our universe, may eventually reverse its effect, leading to a big crunch. This would then trigger a new Big Bang, beginning the cycle again. 10 minutes and 45 seconds. Of course, this raises another profound question. If the universe is cyclic, why do we not remember past iterations? One possibility is that each cycle erases the conditions of the previous one, resetting space, time, and even the laws of physics with each rebirth. This idea leads us to another fascinating hypothesis, one that suggests our universe is not a cycle, but a simulation. 11 minutes and 10 seconds. Some physicists and philosophers speculate that what we perceive as reality could be a simulation, governed by a higher intelligence or an advanced civilization. If our universe was programmed, could the Big Bang simply be the reset of an ongoing simulation? This theory suggests that the conditions before the Big Bang might not be a physical reality but instead a computational process, a reboot of a cosmic system following the end of a previous simulation. This concept, while speculative, has gained traction in discussions about the fundamental nature of reality, especially as we advance in artificial intelligence and computational power. If our universe is a simulation, then the Big Bang might not have been a beginning at all, but rather a carefully designed starting point in a greater structure beyond our comprehension. 11 minutes and 55 seconds. Yet, despite these theories, cyclic universes, inflationary multiverses, quantum fluctuations, and even simulation hypotheses, one question remains: can we ever truly know what existed before the Big Bang? The challenge lies in the fact that the Big Bang marks the earliest moment from which we can gather information. Since time and space themselves emerged from this event, anything before it may be fundamentally unknowable. However, science continues to push the boundaries of understanding. Researchers are developing new ways to probe the universe's earliest moments, searching for imprints of a pre-Big Bang cosmos in the cosmic microwave background radiation, the afterglow of the Big Bang itself. 12 minutes and 30 seconds. If evidence of an earlier state is discovered, it could reshape our entire perception of the universe's origins. It might reveal that our cosmos is just one of many, or that time itself is an illusion created by the way we experience reality. Until then, the question of what existed before the Big Bang remains one of the greatest mysteries of science, a challenge that inspires curiosity, fuels debate, and drives us to seek answers beyond the limits of our current understanding. Perhaps, one day, we will uncover the truth. Or perhaps, like the universe itself, the answer will continue to expand, leading us toward even deeper and more profound questions. As we continue to push the boundaries of our understanding, one thing becomes clear: our universe is far more complex than we ever imagined. Theories about what preceded the Big Bang take us into realms of science where physics, philosophy, and speculation merge. Some scientists argue that before the Big Bang, there existed a primordial quantum state, a chaotic sea of fluctuating energy and potential, governed by the bizarre rules of quantum mechanics. If this is true, then our universe did not arise from absolute nothingness but from a pre-existing quantum landscape. This leads to another fascinating idea: quantum loop cosmology. 13 minutes and 35 seconds. Quantum loop cosmology suggests that space and time are not continuous but instead made up of tiny, discrete units, like pixels on a screen. According to this theory, the universe did not emerge from nothing but from a previous state where quantum gravitational effects prevented it from collapsing into a singularity. This means that before the Big Bang, there may have been a big bounce, in which a previous universe contracted, reached a minimum size, and then expanded again, creating the cosmos we inhabit today. If true, this would provide a direct link between our universe and a previous one, potentially explaining why certain fundamental physical laws appear so finely tuned. But could there be more than one cycle? 14 minutes and 10 seconds. Some theories propose that this bouncing process has been happening for eternity, with universes repeatedly forming, evolving, and collapsing, only to be reborn again. This eternal recurrence of cosmic events suggests that our universe may not be unique, but just one in an infinite sequence of universes. However, this raises an unsettling question. If the universe has been cycling forever, why does it appear to have a definite direction in time? Why do we remember the past but not the future? To answer this, scientists turn to the concept of entropy, the measure of disorder in a system. According to the second law of thermodynamics, entropy always increases over time, leading the universe from order to chaos. But if the universe has been bouncing forever, shouldn't entropy have already reached its maximum? Some researchers suggest that each cosmic cycle resets entropy in some way, making each new universe appear as though it has a fresh beginning. But how? 14 minutes and 55 seconds. One possibility is that the laws of physics themselves evolve over time. If the rules governing space and time change with each cycle, then each universe may emerge with slightly different conditions. This could explain why the constants of nature seem so precisely tuned for life in our universe. Perhaps they are the result of countless prior cycles where different configurations were tested. This idea ties into the evolutionary universe hypothesis, where only universes with stable physical laws survive long enough to create complexity, while others fade away. Could it be that we live in a universe that has naturally selected the right conditions for stars, planets, and even conscious life to emerge? 15 minutes and 30 seconds. If so, this brings us to yet another mind-bending possibility, the anthropic principle. This principle suggests that the reason we find ourselves in a universe capable of supporting life is simply because only such universes can produce observers like us. If there were other universes with different physical laws, they may exist, but they would be devoid of conscious beings to observe them. This leads some scientists to speculate that before the Big Bang, there may have been countless universes that emerged and collapsed, some stable, others unstable, until, by chance, one formed with the right balance of forces to create long-lasting structures. Could our universe be the result of an ancient cosmic process where only the most stable configurations endure? 16 minutes and 5 seconds. While this may sound like science fiction, modern cosmology is beginning to take these ideas seriously. Scientists are developing ways to test for evidence of past universes by looking for imprints in the cosmic microwave background radiation, the afterglow of the Big Bang. Some researchers believe that if a previous universe left behind certain patterns, we might detect faint echoes of it in the very fabric of space itself. If we find these imprints, it would be a breakthrough, confirming that the Big Bang was not the true beginning, but just another phase in an infinite cosmic cycle. 16 minutes and 40 seconds. But what if we go even further? Could there be a reality beyond universes themselves? Some physicists propose that our universe might be part of a larger meta-universe, a vast and unimaginable structure where Big Bangs happen regularly, each giving birth to a different universe with its own laws of physics. This idea, often called the megaverse or supercosmos, suggests that even if we one day understand our universe's origins, there may always be a greater reality beyond it. 17 minutes and 10 seconds. So, where does this leave us? Despite all our scientific advancements, the question of what existed before the Big Bang remains one of the greatest mysteries in cosmology. Whether it was an eternal quantum sea, a previous universe, a cyclic pattern of expansions and contractions, or even something beyond our comprehension, we are still far from a definitive answer. Yet, the search itself is what drives human curiosity forward. With each new discovery, we get closer to unlocking the deepest secrets of existence. Perhaps one day, we will have a theory that fully explains where everything came from. Or perhaps, like the horizon itself, the answer will always remain just beyond our reach, pushing us ever forward in our quest for knowledge. 17 minutes and 50 seconds. Until then, we continue to explore, question, and wonder, standing at the edge of the known universe, gazing into the unknown, asking the same question that has fascinated humanity for centuries.